Hello children, welcome to another session of PYQ JEE Advanced. Today I have brought a thermodynamic question for you, and just look at the question now. A graph is given there which is a plot of entropy at a temperature T minus entropy at 0 Kelvin. That difference on y-axis in joule per mole per Kelvin, and on x-axis it is temperature. Kelvin scale temperature is plotted. You can see two plots there. Two plots can be seen. One is for two phases it is given. The entropy versus temperature plot for phases alpha and beta. Two phases of a substance, alpha and beta at 1 bar pressure is given. St and S0 are entropies of the phases at temperatures T and 0 Kelvin respectively. Now let us go to the question. The transition temperature for alpha to beta phase change is 600 Kelvin. That is what is shown here. Transition temperature 600 Kelvin, and Cp beta minus Cp alpha is 1 joule per mole per Kelvin. Assume Cp beta minus Cp alpha is independent of temperature in the range 200 Kelvin to 700 Kelvin. Between that 200 Kelvin to 700 Kelvin, the difference in Cp of beta and alpha, the difference is not changing. That is the assumption you have to make. And Cp alpha and Cp beta are the values of entropy changes, are heat capacities of alpha and beta phases respectively. The value of entropy change, entropy of beta minus entropy of alpha in joule per mole per Kelvin at 300 Kelvin is the question. You are provided with ln2 as well as entropy of beta minus entropy of alpha is 0 at 0 Kelvin is what you have to assume. Now you can have the data given to us. Let us see what all the data given to us. It is given St alpha or St minus S0 for the phase alpha at 600 Kelvin is given. St minus S0 of alpha phase at 600 Kelvin is given as 5 joule per mole per Kelvin from the graph. It is available 5. And you are also provided with S at T Kelvin minus S at 0 Kelvin for beta at 600 Kelvin is given as 6 joule per mole per Kelvin from the graph. This data is given to us. Now additional data given to us, Cp of beta phase minus Cp of alpha phase is equal to 1 joule per mole per Kelvin, and you are asked to take it as a constant in the temperature range 200 Kelvin to 700 Kelvin. Now it is at 600 Kelvin. So this is constant between 200 Kelvin and 700 Kelvin is given to you. Now this much data, you are also asked to take entropy of beta minus entropy of alpha is 0 at 0 Kelvin. That difference is 0 at 0 Kelvin you can take. Now you are asked to find out S beta minus S alpha at 300 Kelvin. So what is the relation which you know for entropy change with respect to pressure, temperature, Cp? So the formula to be used is delta S entropy change is equal to NR ln P1 by P2 plus N Cp ln T2 by T1. This is entropy change formula to be used here, and at 1 bar pressure, meaning the pressure is constant. So this term gets cancelled. P1 is equal to P2. At 1 bar pressure, the pressure being constant, P1 is equal to P2. This term no more exists, and you can directly use the formula delta S is equal to NCP ln T2 by T1. So let us write delta S of alpha form. Delta S of alpha form will be N, joule per mole per Kelvin. Everything is given per mole. So let us take N value as 1 mole and Cp alpha ln 600 by 300. What is this delta S of alpha means? S alpha at 600 Kelvin minus S alpha at 300 Kelvin is equal to Cp alpha ln 600 by 300. Same way, you can also write it for delta S beta will be Cp beta ln 600 by 300. So you can write it as S beta 600 minus S beta 300 is equal to Cp beta ln 600 by 300. Now I mark it as equation 1 and I mark it as equation 2. You have to find out S beta 300 minus S alpha 300. So from these two equations, easiest way of arriving at it is, from these two equations, easiest way of arriving is just do equation 1 minus equation 2. When you do that, you have S alpha 600 minus S beta 600. S alpha 600 minus S beta 600 plus S beta 300 minus S alpha 300. Hope you got it. Minus S alpha 300 minus S beta 300 comes out to be S beta 300 minus S alpha 300 equal to Cp alpha minus Cp beta into ln 600 by 300, which is ln 2, not ln half. 600 by 300 ln 2. Now you have S alpha 600 minus S beta 600. You have S alpha 600 minus S beta 600. S beta 600 is, or S beta 600 minus x0 is 6 and S alpha 600 minus S0 is 5. So when you take the difference between this and this, S0 beta minus S0 alpha can be taken as 0, that gets cancelled, and you have S alpha 600 minus S beta 600 as 5 minus 6. If you do this minus this part gets cancelled, and you have, because S0 alpha and S0 beta difference is 0. So you are left with S600 for alpha minus S600 for beta is 5 minus 6. That's what you require here. 5 minus 6, which is minus 1, plus S beta 300 minus S alpha 300 is equal to, now you are provided with the data, Cp beta minus Cp alpha is 1 joule per mole per Kelvin. Here you have Cp alpha minus Cp beta. Beta minus alpha is 1. What you have written here is alpha. So that becomes minus 1 into ln2. Or minus 1 plus S beta minus S alpha at 300 is minus 1 into ln2 is 0.69. Or S beta minus S alpha at 300 Kelvin is, you can bring this 1 to the other side, 1 minus 0.69, which is 0.31 joule per mole per Kelvin. This is a numerical question which appeared in 2023 JEE Advanced. So, the only thing you have to bring to your mind is how to find out delta S given temperature change at constant pressure, given Cp of the system. Then delta S is equal to Nr ln P1 by P2 plus Ncp ln T2 by T1. This is at constant pressure. So this term gets P1 is P2. Thereby you can directly use delta S Ncp ln T2 by T1. You have written delta S alpha, which is delta S alpha is S alpha at 600 minus S alpha at 300, which is Cp of alpha phase ln 600 by 300. Same way you have written for beta phase at 600 Kelvin and 300 Kelvin, which is delta S beta is SB 600 minus S beta 300, which is Cp beta ln 600 by 300. Now just see what you require in the question. What you require is S beta 300 minus S alpha 300, for which the easiest way is do 1 minus 2. You got this expression. From this you require this. From the graph you have S alpha 600 minus S beta 600 as minus 1 plus this is equal to Cp beta minus Cp alpha is 1. So we require the reverse, so minus 1 into ln2, and we arrived at the answer 0.31 joule per mole per Kelvin. Thank you, children.